So, hi to everyone. MEM School of Engineering, Department of ECE, subject Linear Integrated Circuits, unit number 3, chapter number 6. So, last chapter we discussed about monolithic IC PLL. So, that is the PLL phase log loop circuit manufactured in the single monolithic IC. Okay, so like that we discussed about pin diagram, internal circuit diagram of the PLL. So and parameters of the PLL like that we discussed in this last chapter. So in this chapter we are going to discuss about applications of PLL. Okay, that is using monolithic ICs. What kind of applications we can develop in the communication area and other electronics applications. Okay, let's see the application of PLL. So we have different applications of PL. One is AM detection, FM detection, FSK modulation and demodulation, frequency synthesizing, clock synchronization. Okay, let's see one by one. So first application is AM detection. So here the PLL is locked to the carrier frequency of the incoming AM signal. Once locked, the output frequency of VCO is same as the carrier frequency, but it is in the unmodulated form. The modulated signal is 90-degree phase shift and the unmodulated carrier from output of PLL are fed to the multiplier. Since VCO output is always 90-degree output of the phase. So this is a diagram for AM detection. It is have a AM input and given to the multiplier phase detector, then LPF, then phase shift of 90-degree of AM. Okay, that is demodulated output conditions. Okay. So the output of the multiplier contains both the sum and the difference signal. The low pass filter connected at the output of the multiplier rejects high frequency commands, gives demodulated output. As PLL follows the input frequency with high accuracy, a PLL AM detector exhibits a high degree of selectivity or noise immunity, which is not possible with the conventional peak detector type AM modulators. So now we are going to detect the FM frequency using this block diagram. That is FM signal given to the phase detector, then output of the phase detector given to the low pass filter, then given to the error amplifier. They fed with the VCO. Here we are using the charge capacitor. That is a coupled capacitor we are connected with the VCO. Therefore, the AC components of the error voltage or control voltage of VCO will represent a true replica of the modulating voltage that is applied to the FM carrier at the transmitter. The faithful reproduction of the modulating voltage depend on the linearity between the instantaneous frequency deviation and the control voltage of VCO. It is also important to note that the FM frequency deviation and the modulation frequency should remain in the locking range of PLL to get the faithful replica of the modulating signal. If the product of the modulation frequency FM and the frequency deviation exceed the del FC square, the VCO will not be able to follow the instantaneous frequency variations of the FM signal. Next application is frequency translation. That means we are going to change the frequency of input. That means using of adding or subtracting the frequency with the some input frequency. Here we have mixer, low pass filter, phase detector, then error amplifier and VC. Okay, we are adding the offset frequency with the input. That is F0 minus Fs equal to F1, and the output F0 is equal to Fs plus F1. That means adjusting the offset frequency F1, we can shift the frequency of the oscillator to the desired level. The frequency translation means shifting the frequency of an oscillator by a small factor. So therefore, the output of mixer contains the sum and different signals. The low pass filter connected to the output of mixer rejects the signal, also gives the F0 minus Fs signal at the output. The F0 minus Fs signal is applied to the phase detector. Another input for phase detector is the offset frequency F1. in the log mode. The VCO output frequency is adjusted to make two input frequency of phase detector equal. Okay. So let's see PLL frequency synthesis block diagram. The PLL can be used as the basics of frequency synthesizer that can produce a precise series of frequencies that are derived from a stable crystal controlled oscillator. Okay, we know that crystal oscillator, it is a oscillator which is produce the different frequency in the output that is divided by M network. It is connected with the phase lock loop. The frequency synthesis black diagram, it is similar to the frequency multiplier circuit, except that divided by M network is ordered at the input of phase lock. Okay, the frequency of the crystal controlled oscillator is divided by the integral factor by M by the process for F oscillator divided by M, where F oscillator is the frequency of the crystal controlled oscillator. The VCO frequency is similar divided by the factor N to give the equal of VCO divided by N. Okay, by adjusting divider count to desired values, large number of frequency can be produced, all derived from the crystal controlled oscillator. So final application is frequency multiplier using PLL 565. We have a N divided network in the output of the VCO and given to the input circuit. So here output F0 is equal to N of F5. That is, we are multiply the frequency with the N factor. We are multiplying the frequency input frequency with the N factor. By selecting the proper value of N network, we can obtain the design multiplication. For example, N value is 6 means it will be output F0 is equal to 6 into F5. Okay, N should not be equal to the 6. It is we have to nearby value. Okay, then only we can use the different application. Next one, frequency shifting keying mode demodulator. In digital data communication, the binary data is transmitted by means of the carrier frequency. It uses two different carrier frequency for logic 1 and logic 0 states of binary data signal. So this type of a data transmission called a frequency shift keying. In this transmission, the receiving end two carrier frequencies are converted into 1 and 0 to get the original binary data. This process is called as frequency shift keying demodulation. FSK block diagram. That is low pass 1, low pass 2, low pass 2. These are the two inputs to the comparator, then VCO. So that value will be taken from the by the VCO and given to the feedback to the phase detector. So here the VC1 value is equal to F1 minus F0 divided by kV, and VC2 value will be F2 minus F0 divided by kV. kV is the voltage to frequency transfer coefficient of the VCO. The reference voltage for the comparators is derived from the additional low pass filter, and it is adjusted midway between VC1 and VC2. Therefore, VC1 and VC2 comparator gives output 0 and 1 respectively. Okay, these are the applications of PLL. Okay, because PLL mainly used in the demodulation. From this topic, we can conclude with the PLL mostly used in the demodulator circuit, because it is defined the log the particular frequency. For example, if you want to log the particular FM station for getting, for example, 98.3 megahertz FM means you have to move to that 98.3. So the input frequency and voltage control oscillator frequency will be matched with the 98.3. So then only the signal will be received. So this concept applied in the most of the demodulation process. So only the PLL mainly used in the demodulation concepts. Okay. Okay, thank you.